What you see here is what we call the pump graveyard. These are parts that have seen more than their share of action, and they show it. But it's useful to know how and why they came to this end. Let's start with this cavitated impeller. Compared to a new one, you can see the suction eye is missing, the discharge vanes are badly ragged, and there are even holes in the shrouds. This kind of damage was caused by the formation and collapse of vapor bubbles called cavitation. Cavitating pump often sounds like it's pumping rocks, and it vibrates a lot as the vapor bubbles collapse. Cavitation has many possible causes, but look for low system pressurization, high pressure drop components like fine mesh strainers or partly closed valves on the suction side of the pump. If you can prevent cavitation, you can avoid damage like this. This is a relief valve from a hot water boiler. Can you see that it's rusted shut, making it almost impossible for water to flow out of the valve? This rusting was caused by improper air control, leading to a very dangerous situation. If we want to avoid this kind of problem, we must ensure that our compression tanks are properly installed and properly sized for the system. This impeller is probably as good as this new one underneath all the lime scale. All this stuff built up in the pump little by little until the flow passages were blocked and the pump couldn't move water through the system anymore. It was like having a brick mounted on the end of the pump shaft. You can easily avoid this kind of problem by making sure you have a closed system so you don't have to add new water, and ensuring that your system water is chemically treated to remove scale-forming chemicals from it. Our last graveyard ghost is this booster pump impeller. Compared to a new one, there's not much left, is there? These pumps operated in heating systems for a long time with a constant supply of new oxygen coming in because of relief valve discharges, leaks, or improperly located compression tanks. The oxygen reacted with the iron in the impeller to form rust, which flaked away over time, leaving this. How much flow do you think you're going to get out of this one? If you apply the principles we've been talking about, your systems will operate more efficiently, they'll last longer, and most importantly, your parts won't end up in the pump graveyard. Here's hoping that all this has been beneficial to you. We're sorry that you couldn't come to the Little Red Schoolhouse in person, but we did the next best thing. We brought it to you. I wish you the best of luck in designing and installing your hydronic systems, and I hope this is useful. Thanks.